Alright, second figures notes part 2. Alright, so now we're going to show you some examples and just kind of go over a few and hopefully make a little more sense so when you do them in class it'll be easy for you. Alright, so here's some of my examples here. Got 13 of them. Alright, and I'm going to go ahead and switch over to where I can write a little bit on this. Alright, so here when I look at number 1 and number 3, you'll notice that they're in scientific notation. Well, whenever they're in scientific notation, it automatically is telling me, guess what? That is the number of significant figures. So for number 1 there, where it's 5.345 times 10 to the negative third liters, well, I already know that those numbers are significant. So there would be 4 significant figures. Number 3, again, 4.200 times 10 to the fifth deciliters. That's telling me that those are already significant. So again, it would be 4 significant figures. Number 5. Alright, there's not a decimal, so I can't count any significant figures until I hit a real number. So when I get to the 7, that's when I'm going to start counting. So I should have 3 significant figures there. Number 7. Alright, 1 million miles. Well, there's not a decimal, so none of those zeros are important until I hit a real number. So when I hit the number 1, that would only give me 1 significant figure. All those other zeros are just placeholders. It could be 1,000,001 miles. It could be 1,000,002. We really don't know. So those zeros aren't significant. Number 9, same thing, not a decimal, so it would only be 1 significant figure. Alright, 11. Now, here's a number that's greater than 1. So if it's greater than 1 and it's got that decimal, I start counting from the left. So there's the 7. So that precedes those zeros. So in this case, I would have 3 significant figures. Alright, 13. Alright, not a decimal again, so I should only have 1 significant figure. Alright, back up to the top there with number 2. Okay, so this number is less than 1. So if it's less than 1, again, I'm going to count from the left. None of those zeros are preceded by a number, so I can only start counting when I get to that real number 7. So in this case, there would only be 2 significant figures. Alright, number 4. Okay, well, there's a decimal, and all of those zeros are in between 2 real numbers, so I have to count them all. So I should have 5 significant figures there. Number 6. Okay, start when I hit a real number. Well, when I get to 7, that's when I'm going to start counting. So I should have, again, 5 significant figures. Number 8, again, less than 1, so I'm not going to start counting until I hit a real number. So that's not going to happen until I get all the way to the 3. So in this case, I would only be 1 significant figure. Number 10, again, there's a decimal, so now I can count both of those numbers. So I should have 2 significant figures. And then 12, same number as above, but there's not a decimal, so now this time there's only 1 significant figure. Alright, so hopefully that makes a little more sense, and as we're working through them in class, you're getting a fairly good understanding of significant figures. Alright, so back to our slides here. Alright, so when I'm rounding off to a certain number of sig figs, so sometimes, right, you'll see a question where it says that you need to round off to a certain number. Alright, so here's some examples. So if I needed to round off 107.5 to just 2 significant figures, well, I need to take into account that the 0 between a real number would count. So it can't be 108 because that would be 3 significant figures. So I have to go higher. So it would need to be 110 in order for it to only have 2 significant figures. And I couldn't put a decimal spot there. It would just have to be 110. Alright, the next one there, 7.30 to 1 significant figure. Alright, well, I'm going to go ahead and have to round down. So in this case, I would just round it down to 7, and that would be 1 significant figure. The third one there, round that scientific number, 4.7530 times 10 to the negative third, to just 2 significant figures. Alright, well, that one's fairly easy because that 7 can just become an 8 because of the 5, so it becomes 4.8 times 10 to the negative third, and that would be 2 significant figures. Alright, the last one there, it wants me to round it to just 1 significant figure. Alright, well, that one, again, since it's not above 5, the 3, 4, I'm going to go ahead and want to round it down. So it would actually be 0.0003. That would be the 1 significant figure. Alright, so that's how you do some rounding when it comes to sig figs. Alright, so if I'm handling measurements using sig figs, another rule to kind of keep in mind is whenever we use measurements in mathematical calculations, It cannot be more accurate than our least accurate measurement. So what that means is, if I'm measuring something with a meter stick that is only in centimeters, and then I'm measuring something else that's a meter stick with millimeters, well, I can't have an answer that's in millimeters because my other measurement, which was in centimeters, is not as accurate as millimeters. So I can only be as accurate as the least accurate, which in that case would be the centimeters, not the millimeters. So we can't use more sig figs in our measurement with the least number of sig figs. Okay, so here's some examples on the next slide. Alright, so I need to figure out the number of sig figs here and see how they cannot be more than the least, alright, than the fewest given sig figs. Alright, so let me switch over here to where I can get manipulated here. Alright, so I've got 0.250 centimeters times 2.0 centimeters. So the first thing I've got to figure out is go, okay, well, the first number, 0.250, has 3 significant figures. And then the 2.0 has 2 significant figures. So when I multiply them, my answer can only have 2 significant figures. So that means I should end up with a decimal there, right? 0.50. Alright, pardon my writing, not the best. But I can only have 2 significant figures because that's the least. Okay? When I look at the second one there, 5.0 times 5.0, well, they both have 2 significant figures. So in this case, I have to still have 2 significant figures for my answer. But that works out nicely because 5 times 5 is 0.5. Okay? The third one there is 5, just one significant figure, times 5.0, which is 2. So that means that my answer can only have one significant figure because that's the least number of sig figs. So in this case, the answer would still be 25, but I can't have 25. I've got to round it up to 30. So that's what I would end up there. Alright, and then the final one, 5 times 5. Again, just like the one above, they both have one significant figure, so my answer can only have one significant figure. So in this case, again, it would have to be 30 for the answer. Alright, and then when I look at the last one here, 640 meters squared divided by 8 meters. Well, I've got 4 significant figures in the first one, 640.0, and I've only got one significant figure in the second part. So then that means that my answer can only have one significant figure. So when I divide this, it should end up as 80, but I can only have an 80 without a decimal. That way that 0 doesn't count as a significant figure. Alright, so that's how we do some rounding and making sure that our sig figs only have a certain number compared to whatever the few or the least sig figs that you were multiplying or adding or dividing with. Okay? Alright, back to our slides here. Okay, so now I'm going to go to the next one here where we're talking about adding and subtracting. Alright, so when I'm adding and subtracting, I don't use the sig figs. I have to look at the decimal place. And so really this is kind of going back to when you were a little kid and you had to match up the decimal place up and down and then you had to add and subtract that way. This is really the same thing. So your answer cannot contain more digits after that decimal point than the least number of digits after the decimal point given. So zeros do count here, so you got to round after that operation. Alright, so when I look at number 1 here, 6.000 plus 0.06, well, I just look at how far it goes past the decimal place. Well, number 1, that 6.000, is 3 spots past the decimal place. And then the second one, 0.06, is 2 spots past the decimal place. So when I add those together, I can only go 6.06. I couldn't put a 0 after that 6 because that's too many spots past the decimal place. I can only go the least number. So in this case, I can only go 2 past the decimal place. So my answer would be 6.06 for the first one. And then for the second one, well, I only go 1 past the decimal place for that 0.8. And I go 3 past the decimal place for that second part. So 0.8 minus 0.243, well, if I wrote it all out, it would end up being 5.57, right? 0.557. But I can only go 1 spot past the decimal place. So here I've got to do some rounding. So 5.57, I could round it and make it 0.6. And that's about as far as I can go. Remember, I can't go further than my least decimal spot. Alright, so just keep that in mind. Okay, so that's sig figs right there. Alright, so that ends our presentation, and hopefully everybody got it. Please go back, make sure you got it all copied down, and we'll see you guys in class.